This year, we're going to talk about what I think is the hardest challenge in site reliability engineering, which is automating system recovery. That's right, system, not disaster or incident or outage. These are all just words we use to describe different levels of something's up with the system. So, and it ranges, right? So from a small performance regression in some corner of your app, up to whole thing is down, people cannot use their credit cards, your engineers cannot get into your data center to fix it because the doors authentication system is within it and it's offline, right? Hope no Facebook engineers are in the room. Sorry, Meta. But impact itself, it's not so interesting. Once you've done this for a while, you can easily envision the different ways your system can go bad. It's not that wide of a spectrum either. It's either up or down, responsive or slow. And that's all your users see anyway. So what's up with the system is, to me, way more important. What happened and why it happened. What's the root cause or contributing factors or however you call it. Basically, what's the set of necessary conditions that needed to be met for the impact to happen. And here I want to spend a couple of minutes introducing something that I've started doing more recently. And that is, when faced with a challenge at work, also off work, but at work, I would ask myself, what could have been done differently a decade ago that would have prevented this? I do this all the time. You can do this on incident retros, for instance. How many times do we focus only on the recent changes that led to an incident and not the underlying architecture decisions that led to those changes that then led to the incident? And so, sure, that bad scale-up operation might have been the triggering event. And as we saw in this year's Void report, bad automation might have been also a contributing factor. But why a workload with scaling a demand made it through without auto-scaling is surely a more interesting conversation to have. Where in the design phase did we miss it? That's surely more interesting. And not because we're looking for a design decision or an individual to blame. 10 years ago, I would have probably made way worse decisions than those before me. Instead, we do this so that we can learn and prevent these problems from happening again. As you do this over time, you'll realize that there are a handful of things that come up more often. You'll start to see trends and patterns. Those are where you want to double click on. Be careful, however, with confirmation bias. Try to do this with some colleagues if you can, because you can very much easily confirmation bias your way into thinking that one single problem that you detected is the root of all evil. That's not the case. Try to do it with some colleagues. Don't talk to each other for a while, and then you reconvene and you compare where you landed and see where you're at. Another thing you'll realize is just how important architecture decisions and day zero decisions are years down the line. How painful it is to unwind a decade of patches on top of patches. And just how much of your daily energy today is spent remediating that. That standardization effort you're going through today is the direct consequence of not having had one standard, and just one, years ago. And more interestingly, where did that gap come from? Is it because no one thought they owned that piece for a while until you did? Is it because there wasn't a strong tech leadership position? Those are the more interesting questions to have, especially at the org level. Breaking that monolith up into pieces or splitting that database was also a design miss. That migration you're going through is a design miss. And sure, all of this is easy to say in hindsight. Maybe it was that the only choice you had was that, or perhaps it was a perfect choice and your requirements changed. And furthermore, we're surely making problems and issues today and mistakes today that we'll only realize were mistakes 10 years from now. But there's surely something that could have been done back at the drawing board before that would have made your life easier today. Let's focus on that so that we don't repeat those mistakes. And same goes for incidents, right? Most incidents are resolved at the drawing board on day zero, when the service is not much else but an idea. And I'd say it is our duty to identify and understand these mistakes so that we don't replicate them in the future. So, what could have been done differently a decade ago? One last thing you'll realize doing this, ultimately, and this is the main point of the talk, so if there's anything you need to live with, it's this. It's that reliability cannot be an afterthought. I'll say it again. Reliability cannot and shall not be an afterthought. It needs to be considered from the moment your idea begins development, from the very beginning of the technical design phase. And now, a question for the audience, a liveness probe, like Sarah said. This is probably the most asked question here at SREcon ever, but bear with me for a second. Raise your hand if you've read this book. All right, so pretty much the entire room. Now, raise your hand if you've also read this book, the second one, the workbook. That's not so many. That's exactly the point. So, for those who missed it, the workbook contains this chart over here. It plots Google's alleged SRE involvement over a service's life cycle. As you can see, they begin engagement at the very beginning, when the idea starts development, and as soon as it begins turning into a product. Well, and you know what? They got it right. But I feel like this piece of information was missed when the rest of the world adopted SRE. And maybe it's because the book didn't sell as well. For every 5 SRE books, only 1 workbook was sold. Maybe it's because most of you lowered your hands and didn't raise it when I asked the second question. I don't know. And don't forget, this room is peak site reliability engineering. The companies that brought you here today are not your usual SRE practitioner. And not only that, but also from the companies themselves, only you are here today. So this is not a good sample. This is not, if we had everyone in here, the ratio of people that would have raised the hand for the workbook would have been much lower. And for the rest, the other 99% of SREs that are not here today, this is how it actually looks like. 0 engagement at the beginning of the service, and then it only ramps up, and it does way more because you need to make up for the engagement that you didn't do way later during runtime. And one could say and make the argument that, sure, if you're not doing things right, you're not doing site reliability engineering. But I don't find that's fair. First, it doesn't align with the common thrown around advice that you need to take SRE and fit it to your org. Either we choose what the principles that you cannot be violated are, and we state that clearly for people, or we don't say that. And furthermore, it's also condescending. The other 99% of SREs out there might not be doing SRE perfectly, but they still run 99% of the systems that run our economy. It is our duty as SREs to let them know these things and communicate these principles clearly so that they don't miss on it. Again, reliability cannot be an afterthought. Now, another question for the audience. Please raise your hand if you're an SRE manager, VP of engineering, director. Basically, you have direct SRE reports or otherwise. All right, so that's a good chunk. All right. So this next bit's for you or anyone that wishes they would have raised their hand, if anyone. Do you know who this gentleman is? Does anyone know? Anyone? This is Melvin Conway. Conway as in Conway's Law. Conway's Law states something along the lines of, the architecture of the software you're building will closely resemble that of the human structure you set out to build it. I'll say it again. The architecture of the software you're building will closely resemble that of the human structure you set out to build it. Basically, org design, team structure, is software design. And as such, I want to turn it around and throw a question, an idea for the room, for the managers to ponder on. If Conway's Law stands and reliability considerations need to be taken care of since day 0, should SREs influence team structure decisions? Should SREs be in the room when the team is structured? Because it influences the software design. Not that I have an answer, but just a good panel topic for next year, if anything. So, what could have been done differently a decade ago? Most of the times, the answer is going to be putting SREs in the room earlier, engaging as soon as the idea begins development. I lied before. This is the ultimate reliability challenge. This is considering the reliability constraints since the moment the idea is born, that's the hardest part, especially the cultural shift around it. Whether SREs need to be in the room, actual SREs need to be in the room or not, that's up for debate. Like Niall said, it's not SRE people that we need, it's SRE thinking for the ideas and principles to permeate all across the org. The mindset and the cultural shift that make reliability a top-of-mind requirement if, and this is a big if, you're building reliable systems. I'll come back to this later. It's similar to what happened with security. After decades of insecure software, it is now widely accepted that software must be secure by design. We expect developers to build systems and software that are grounded on security principles like least privilege permissions or secure handling of secrets. Even folks outside of the software engineering field are getting trained on not leaving their laptop open on some conference room, right? So this is because we as organizations, as society, we have understood that security is a team effort. Same thing happens with reliability. It needs to be a thing that is accounted for since day zero and a thing that's in our minds as we operate daily. Another similar parallel to this is observability. We just heard Charity say the other day that the next step in observability is treating observability as a property of a system and therefore doing observability-driven design. I'll one-up that and say that what we actually need is reliability-driven development. We need to take into account reliability since day zero. So what does any of this have to do with automating system recovery? I'm getting there. Let's go back to incidents and figuring out the root cause. I don't want to call it root cause because I know it's a little bit of a loaded term. Some people are starting not to use it, and it's being phased out for a good reason. Some people use different terms. Basically, when I say root cause, just listen the set of necessary conditions that needed to happen for the incident to happen. There's no buzzword for that. If anyone wants to invent one or tell me one, that's probably a better name than root cause or contributing factors or triggering event. So as much as we engineers like a good troubleshooting session and diving deep into a problem, and that feeling when you find the needle in a haystack and it all just clicks together, in the middle of an incident, priority number one is still recovery. Doesn't matter if we don't figure out why just yet. We just need to be back in business. That's the top one priority. It's so much so that it's figuring out the root cause might be top 3 for me. It's right below recovering quickly and communication with customers, which, by the way, for a non-technical problem, a lot of us still have a lot of runway there and things to improve. How many times have we joked around with fellow SREs about some service being down and the status page being green for 30 minutes? I'll turn it around. What have you done to improve your comms to customers? Because if no one did this wrong, it wouldn't be a problem. Something to think about. Is this one of these things where 80% of responders think they're above average, much like driving skill? Anyway, back to recovering quickly. This is where I want to introduce generic mitigations. Now, this part is mostly based on Jennifer Mace's article there. You can get the slide later, so no need to take a picture. But it's an excellent article. It basically introduces generic mitigations as panic buttons that incident responders have in the middle of an incident in order to mitigate the impact without knowing its root cause. They are great in that they can severely reduce the time that the impact happens and get you back to a stable state without having to spend the time digging deep into a problem, because as systems get more complex, it's harder to figure out what happened, especially if you don't have the tooling set from day zero. In her article, Macy describes a number of generic mitigation categories, such as these ones. So the first one you probably know and love, it's binary rollback. Basically, you rolled out 1.1, it's bad, going back to 1.0. That's it. Most people can do this today. If you're using Kubernetes, you can do this today. Tooling is already set there for over a decade now, so it's mostly there. The next one is also interesting, is data rollback. So if you have a system that depends on the data that's stored for it to render, or an application that needs the data to be healthy, like good looking before rendering it to the user, you can point-in-time recover back to a point in history where your data was good and then return to stable state. It's not perfect. You might lose some data, or you might have to then backfill that data somehow, the data that you missed, but it's good enough if it brings you back. The next one, this is also very interesting, is degrading. For message-based systems, this is somewhat easy, right? If you're processing 1,000 queries per second, you can gauge that down to 800, and then if that alleviates the pressure on the system, you're going to trade a little bit of latency in exchange for the system still being available, so it's probably a good trade-off. This one is also very interesting in that Monday's talk from the Google Maps folks, they also introduced a thing they do, which is very much in line with this, which is for search results. If the time it would take to get the results was more than a given threshold, they would start to lower the quality of the data so that the results were returned quicker, so that the users would get something, even if it's not perfect, and they wouldn't leave. That's very interesting. I wish they had double-clicked on that. That's another good topic for next year. Upsizing. This is also one that pretty much everyone can do today. It's basically scaling up in any way, horizontally, vertically, however it is for your specific system. It's basically just throwing more resources at the system. It's somewhat easy compared to the other ones, maybe. I'm not saying easy because these are easy. All of these require your system to support them. I'm just saying that most of these upsizing and binary rollback are somewhat common in that most folks here can probably do them today, because things like Kubernetes and such and AWS and other clouds have made it easier for people to do it. But again, none of these are easy. You need to build for them. Again, it needs to be a day zero constraint. You can also block and quarantine. These are especially useful if you have a given user that's particularly annoying. You can assign them to a read replica specifically to not impact everyone else's performance, or you can block them altogether and then handle that with customer support or something. And then in Mace's list, draining was second to last, not the last one, but this is the one we're going to double click on, so that's why I left it to the last one. Draining is the act of moving your workload from one place to the other. So if you have two clusters, one that's healthy, one that's not, you can move the unhealthy stuff over to the healthy cluster and in hopes that that will fix it. That also applies to regions, which is the most common scenario when we're talking about disaster recovery. So that's where we're going to double click on. What if we had a thing, a button, that no matter what happens, whether it's a small regression or a meteor hit US West 1, we press it, and in 5 minutes, we're back in business in some other region. I'm sure some of you have heard this idea before. You might have even pitched it yourself because it's not anything revolutionary. But how can we do that? How can we switch regions in 5 minutes? Now, for some of y'all, your brain might have gone into gear already, and you may be thinking, OK, if I had a standby copy of my data in some other region, and then I could host my traffic over somehow else, then I could probably just scale up the services in one end and then just promote that thing. Then we can script it all together, and that's it. Well, I know that because that's precisely what we did. I'll get to it later. But that's too tactical. We're focusing on our existing constraints today, and that's limiting our thinking. Think about it. We're talking about dynamically moving workloads here. We've solved this problem before, right? We used to know, as an industry, we used to know which physical host did our service ran, which physical place did our workload run. How did we get so good at moving workloads between hosts? We stopped treating them like hosts and started treating them like groups of hosts. Pets versus cattle, remember? Now, next step was moving out of the host and moving into the data center. How did we get so good at moving workloads between data centers? We started treating them like individual data centers and started treating them as availability zones within a given region. But they're still separate data centers, and we move workloads there all the time. So how should we go around moving workloads between regions? We stop caring about regions and start designing for the global scale, for the planet scale. Now, none of these leaps in workload location flexibility came without us having to rethink how we design software. All of these came with a lot of changes on the dev side. Why would we expect region-to-region failovers to not have the same requirements? Now, this goes back to reliability being a day zero concern. You cannot do this effectively 10 years later. Reliability cannot be an afterthought. So, with that said, what did we do? Well, We rewrote all our 215 services and then redid our data and Kubernetes platform so that we could, not just kidding. We just did exactly what I said before. We shipped a copy of our data to some other region, automated it away, and that's about it. It's fancier than that. We built a framework around it that lets our platform engineers write the automation code that runs underneath it, and then the developers use that in a developer-friendly way, to put it some way, that lets them clearly state programmatically what the steps are for each of those 215 services to be failed over from one place to the other. It's sort of like an opinionated, simpler, collaborative Ansible in that all our failover instructions are in just a bunch of YAML files. It's not perfect. It will never be perfect, and that's the point. We are working with the constraints that we had, and so we did not design for reliability. We did not design for disaster recovery since day zero, and therefore we had to patch our way around it. This is a patch. It works fine. It's a great success for us because it delivers on what we want, but it's not perfect, and it will never be. It's just another patch. So I want to close with some thoughts. So I come from Barcelona, and I work for a globally distributed team, and so half of my team is mostly based in San Francisco. So last night, we took the opportunity to have dinner together. And my manager, my current manager, and some other folks were explaining to me the stories of the past. Basically, how was Thousand Eyes grown from a garage up to what it is today, and just how janky everything was in the beginning. Like, I'm talking like bash scripts everywhere that were fragile to the limit, and that they would lengthen that as much as possible for as long as it lasted up until it was a really pain in the ass, and then they fixed it. And that's been Thousand Eyes history since the very beginning. And it's over 10 years now. We're over 1,000 employees within an over 100,000 parent company that's Cisco, and it's thriving. Like, we're growing a lot. The team's great. The work we do is great. And sure, this is all to say that take this advice, everything I said, and everything everyone says up here with a grain of salt, with the POV of the speaker. I joined this company 2 years ago when everything was already flying, everything was already working, there was revenue already, we were even acquired already, so like don't even need to worry about that. So my day-to-day job is fixing the messes of the past and preventing the messes of the future. So when I think about preventing the messes of the future, I of course think that reliability should be a day zero concern, because that's where the messes of the past come from, and I've seen just how painful it is to fix them. But that may not be your case. All of this advice only applies if you are in that position. We are a big company. We are expected to deliver reliable services, and as such, we need to think about reliability since the day zero. This does not apply to you if your main goal, if what you're optimizing for is delivery. If you're a young startup that just started, don't waste a year of your time just going out and making everything perfect, adding the perfect observability platform, adding the perfect developer platform. You might not even have developers for that platform to use. So try to make it and optimize for what your goals are. And then, of course, if you have the resources, if you have the people, especially the people, if you have the money, if you have the time, then take reliability as a day zero concern. But if you're not, then there's no point in that. Don't friction your way out of the market just by adding all of these requirements, perfect observability, perfect scalability, perfect reliability, if you don't need it. What you need is just some way that gets you out into the market, gets some money in, and then you can spend the next 5 years with a positive bottom line fixing those messes. But there's no point in wasting the VC cash in doing everything perfectly. No one got there that way. But again, going back to it, if you are a big company, if you're building services today and you have the time, you have the people, and you have the resources, then reliability cannot be an afterthought. And I'm bringing here the big if you're building reliable systems. That's the thing. Make sure you align on your goals first before you start adding requirements to it. Reliability is a requirement only if that's your goal, building a reliable system. Thank you all for listening. That's all. I'll take any questions you can take.